Okay, today we'll be doing geometry. So, yeah, we'll be doing geometry and we'll be focusing on lines and triangles. Okay, so we'll be focusing on these two things because, they form the basis of most of mathematics geometry, except for when you get to circles and stuff. But triangles will help. In any case, we're going to be focusing on the very smallest parts. So, yeah. Okay, so we'll be starting with two straight lines that we'll be having here. Okay, so we have four angles. We have one there, 2, 3, and 4. Okay, these angles, okay, so these are straight lines. Okay, so one of the first things that we can say is that 2 is equal to 3 and 1 is equal to 4. Okay, angles. Angle 2, okay. And the reason being is that it's vertically opposite angles. So that's one of the first laws that we know of lines. So we have vertically opposite angles, okay? But now we will get to another set in the same thing. Now we have these angles. Now we know that here is point, and that can be point A, B, C, D, or in any case. But the angles around here, around this point, is equal to 1, is equal to 360 degrees. So 1 plus 2 plus 4 is equal to 360 degrees. So if we were missing one of them, and that was like x, then we could just and have that added up and subtract that from 360 to find out what x is. Okay, but now there's also another thing that we can look at. Okay, that was angles around a point, but now we can also see that this is two straight lines. So let's say if it was just like angles around a point. Okay, this is not a straight line, but this is, okay. But so it still adds up to 360 most, okay. If we look at this, then we see there's a straight line and there's another straight line. So angles on a straight line, so 1 plus 2 is equal to 180 degrees. 180 degrees, okay? So we can tell that because it's a straight line. Angles in a straight line is 180 degrees. Any angles on a straight line. Okay. Then now we get, and we're gonna have parallel lines put into here. A parallel line, another parallel line. See that line? So these two lines will never meet. Okay. And now we have a straight line going through these two lines, and we have now 1, 2, 3, 4, 5, 6, 7, 8. Okay? Okay, so now we can tell a few things from this. We can say that angle 3 and angle 6 here are equal to each other. So 3 is equal to 6. Okay? And the reason being is that it's alternating angles. It's alternating angles. Okay? And yeah, so those are alternating angles, and you can see that it forms like a Z shape. If you see, it's a Z shape basically. Okay? But now we can also get another thing from this, and we can see that angle 1 is equal to angle 5, or angle 3 is equal to angle 7. And the reason being is that it's corresponding angles. So 1 is equal to 5. Okay. Now, like, it can work for multiple ones as well, because, like, 3 is equal to 6, okay, but 3 is also, okay, and 4 is equal to 5, because those are alternating angles, and 1 is equal to 5, 2 is equal to 6, 4 is equal to 8, 3 is equal to 7. And we can also tell that 3 is equal to 2, because it's vertically opposite angles, 1 is equal to 4, because of vertically opposite angles, and so on. Okay, now we also get co-interior angles. So if we say 4 plus angle 4 plus angle 6 is equal to 180 degrees, and that's co-interior angles. Okay, those are co-interior angles. So we can say that the reason why is that, like, if you think about it, 6 and, because here we said angle 6 is equal to angle 3, okay, and now if this is a straight line, so we add 3 and 4 would also equal to 180. Okay, so with alternating angles, you also notice that it forms like a Z, okay, and then with co-interior angles, it forms like a U, or something like that, or a U, or a U shape. So with alternating angles, and then, which is like that U, and the Z is corresponding co-interior angles is that U, and alternating angles is in that Z. Okay. But now we're moving over to triangles, and we'll be doing similarity and congruency in triangles. Of two triangles. Okay. And this side, that side. Okay. And then the angles. Okay, so the angles, so there's 3 different ways of telling. Either you see 3 sides that are the same, that are of equal sides, so this side and that side, this side and that side, and that side, okay? Or you do side angle side, okay, so an angle and then, okay, so more like this angle, right? Like this angle and this angle, this side, this side, this side, this side, and then these 2 angles, okay, are the same. Or you have 2 angles and then 1 side, okay, so then these 2 angles and then one of these other sides or something. So these 2 angles and then one of those sides also equal. But with similarity, all the angles are equal, but the sides are not necessarily the same length. Like you would have 2 triangles, the ones may be smaller, but they're all in proportion to each other because the angles are the same, okay? So all the angles are equal to each other. All the corresponding angles are equal. But this side, let's say this one is 1, 2, and 3. This side, the length is 2, 4, and 6, okay? So you can already tell, okay? So to prove that it's similar, then you either prove that the angles by saying that they're given, or you work out the angles, so on. Or what you can do is say, okay, so you have 2 over 1, so these 2 corresponding sides is equal to 2, and then 4 over 2, 4 over 2 is equal to 2, and 6 over 3 is equal to 2. So therefore it's similar, okay, so that's a sign for similar, and the sign for congruency is just 3 lines like that. Okay, so by proving that they're all in proportion was another way of saying that they're similar, okay? Now we'll have a question. Say we have two triangles, and they tell us that they are similar, okay? But they only give us this. That's 2, that's 3, that's 4, and then they have x, and then they have 6, and then they have 9. Now we have to work out what x is. But first, we need to find out, because now we know that they're in proportion, so we can just find out what the proportion is. So let's just say 9 over 3. Or we can say 3 over 9, it doesn't really matter. Okay, so 9 over 3 is then equal to, okay, but because we know that it's in proportion, that we can also say that x over 4 is, sorry, that's not supposed to be a plus sign, it's supposed to be equal sign, so x over 4 is equal to 9 over 3, okay? And 9 over 3 is then equal to 3, okay? Now we work out what x is. So now we know that it's 3. So x over 4 is equal to 3, okay? So what you can do is that we times by, we times the 4, so it's 1 over 3, okay? So we times this by, so we times this by 4 because here we're timesing it by 4 to get rid of this 4 at the bottom, okay? Which means that x is equal to 3 times 4, which is 12, okay? So x is equal to 12. And like so they'll give questions like that, and then you have to work out how they're similar, and you have to work out what x is, because they give it to you that's similar, okay? So yeah, that's everything about similar and congruency in triangles. It's also everything about lines and so on, is that the angles, alternating angles are equal to each other. Okay, vertically opposite angles are equal to each other. We also learned that, so you get vertically opposite angles. Okay, then you angles around a line is 180. Angles around a point is 360 degrees, sorry. And then we have with parallel lines, and we have alternating angles, corresponding angles, and we have co-interior angles. Okay, and then with triangles, with congruent triangles, side, 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 angle, side, angle, angle, side. And with similar triangles, then all sides are in proportion, to each other, okay? So that's with congruency, and that's with similarity, okay? So that's everything that we did today. I hope you guys enjoyed the video, and remember to subscribe.